Hello students, it's Mr. D'Amico with another algebra lesson for you. So far we've been talking about solving linear equations. Today we're going to be talking about solving literal equations. And our goal is to solve literal equations using algebraic properties. So the first question is, what is a literal equation? Well, a literal equation is an equation where the variables represent known values. And more specifically, a literal equation has more than one variable. It has several variables. Sometimes there's more variables than numbers. And the solution to the literal equation has variables in it. So for example, instead of y equals 5, our solution might be y equals 5x plus 2z divided by 5. Okay. When you look at this equation, this literal equation, this actually has all variables, and it doesn't have any numbers other than the c squared exponent being 2. But solving a literal equation follows the same logic as solving a linear equation. In other words, you want to get the variable that you're solving for by itself. So since we're solving for c, we would like to get the c by itself. So just like when you're solving an equation for y, you want to get the y by itself. So how are we going to do that? Well, what I would do, if I want to get the c by itself, there's one key idea whenever you're solving an equation, and that's to do the opposite. For example, if it's x plus 5 and you want to get the x by itself, you do the opposite of plus 5, which is minus 5. So that's the one key idea, whether you're solving a linear equation, whether you're solving a quadratic equation, or in this case, if you're solving a literal equation. We want to do the opposite. So if I want to get that c by itself, first of all, it's a c squared, and right now m is being multiplied. The m is being multiplied by the c squared, so I want to do the opposite of multiplying by m, which of course is dividing both sides by m. So I'm going to divide both sides by m, and that's going to leave me with e divided by m equals c squared. Okay, so I still want to get the c by itself because that's my goal. So what I have now is I want to do the opposite of squaring. What is the opposite of squaring? Well, taking the square root is the opposite of squaring. So I'm going to take the square root of both sides. So now I have the square root of e divided by m equals the square root of c squared. Well, the square root of something squared, those are opposites, so they'll cancel out. So that will leave me with just c equals the square root of e over m. Now I've got the c by itself. That's the answer to my literal equation. Next example, we're going to solve for d. Now there's no squared here. There's actually more numbers in this one, so I want to get the d by itself. Now if you see, there's a lot of things happening here. There's a 2 being multiplied by the d, then we're adding 1 to it, and then we're dividing by 3. So if we think about it, let's eliminate the fraction first. The opposite of dividing by 3 is multiplying by 3. So I'm going to multiply both sides by 3. That's going to leave me with 3c equals 2d plus 1, because again, the opposite of dividing by 3 is multiplying by 3. Now to deal with that plus 1, we can subtract 1 from both sides. 3c minus 1 is equal to 2d, and then I almost have the d by itself. So right now we have the 2 times the d. The opposite of multiplying by 2, of course, is dividing by 2. Those 2's will cancel out. My final answer is d is equal to the quantity of 3c minus 1 divided by 2. Okay, example number 3. We're going to solve for v. Now, if you notice in this problem, we haven't had anything that's happened like this yet. What we've had is only one variable of each type, but in this problem, you can see that there's a t there. There's another t here. I know that it's squared, but we have a t squared and a t. In other words, we have the same variable in two different terms. Now, since we're not solving for t, this is actually very simple, but if we were solving for the variable t and it's in two different terms, what we're going to have to do then is we're going to have to factor. But because we are not solving for t, we don't have to factor. I'm going to explain that again after you see what we do in this problem. So let's solve for v. Okay, I want to get the v by itself. So what I'm going to do right now is I'm going to add gt squared to both sides, because that'll get the v term by itself, the vt. So if I add gt squared to both sides, that'll leave me with h plus gt squared equals vt. Now I'm just one step away. To get the v by itself, I can just divide both sides by t, and that's it. So the t's will cancel out here. Those t's will cancel out. So v is equal to h plus gt squared all over t. Again, if we were solving for t, since there's a t in two different terms, if that's what it was asking us to solve for, we would have to factor. So that might come up later. Be ready for that. But in this one, we did not have to factor because, again, we're not solving for the variable that's in two different terms. The v is only in one term, so we did not have to factor at all. All right, number 4, last one. We're going to solve for capital I. And there's a lot happening here. You can see there's some adding, there's some multiplying, there's a fraction. Let's deal with the u first, and let's do the opposite of plus u, and let's subtract u from both sides. So now we have e minus u equals 1/2 times capital I times w squared. Okay, a couple of different options here. I'd like to deal with the fraction if we could right now. So the opposite of multiplying something by 1/2 is dividing by 1/2, which is also the same as multiplying both sides by 2. Now, if you notice what I did over here, first of all, 1/2 times 2, that cancels out, that's opposite. But if you look over here, 2 times the quantity of e minus u. It's not 2e minus u. So I represented that with a parentheses. 2 times the quantity of e minus u. The other thing you could do is you could write 2e minus 2u if you wanted to as well. All right, last but not least, we have capital I times w squared. So the opposite of multiplying by w squared is dividing both sides by w squared. Final answer, capital I is equal to 2 times the quantity of e minus u all over w squared. Okay, what I'd like you guys to do now is to try number 5 and 6 on the back of the worksheet on your own. The answers are provided for you. Your answers should not look like this, but if it does, we can talk about that in class tomorrow. Please write any questions that you have on that right-hand side in the box there where it asks you to, and see if you can get the answers that I got for you. If not, we will talk about them in class tomorrow. Thank you so much for watching this video. Have a great day, and I will see you guys in class tomorrow. Bye, guys.